Alright, hello everyone, and welcome to our lesson on rocks. Yes, rock. Alright, we've already done a lesson on minerals. Hopefully by this point you've already seen that, so we can go ahead and move straight on into rocks from here. On slide 2, today when we talk about rocks, we're going to be talking about the different ways that rocks are formed and how these different processes create different types of rocks. So we're going to be talking about this cycle, the rock cycle, how we go from one type of rock to another. First, basic definition. Rocks are any solid mass of mineral or mineral-like matter occurring naturally as part of our planet. Alright. Now, in that rock cycle, there are several different types of rocks, and we're going to look at how we go from one to the other. But first, let's go over a few definitions. The first type of rock we're going to talk about is igneous. Igneous rock is formed by the crystallization of molten magma. Let's look at a few words in that sentence. Go over the definitions. Magma is liquid rock inside the earth. We know that deep inside the earth, temperatures are much higher. It's very, very hot. It's so hot that rocks actually melt. So they go from being a solid to a liquid. They go from a solid state to a liquid state. This liquid rock, this very hot liquid rock, is called magma. Now that's what molten means, liquid, that hot liquid. When that magma cools, it actually freezes. That means it goes from a liquid to a solid. So we go from liquid rock to solid rock. And that's what that word crystallization means. So that hot liquid magma freezes into solid igneous rock, or molten magma crystallizes into igneous rock. The next type of rock we're going to talk about, sedimentary rock. Sedimentary rock is formed from the weathering products of pre-existing rocks that have been transported, deposited, compacted, and cemented. A lot of words there to look at. Transport simply means to carry. And deposit means to drop or to put in place. So streams and rivers, when they run through an area, that moving water can actually carry small pieces of rock and then drop them in other places. So if a river, for example, if a river flows down the side of a mountain, it can carry small pieces of rock with it and then drop that rock in low areas where the water is moving slowly. So it transports and deposits rock. And finally, the third type we're going to talk about, metamorphic rock. To understand what metamorphic rock is, it helps to understand what that word means. Metamorphic simply means to change. Metamorphic rock as we see on the slide, is formed by the alteration of pre-existing rock. Alteration, again, means to change. The alteration of pre-existing rock deep within the earth by heat, pressure, or chemically active fluids. So, pre-existing rock, perhaps a sedimentary rock, can be heated and crushed, and heated and crushed, and heated and crushed, and turned into metamorphic rock. It's almost as if sedimentary rock is cooked into metamorphic rock. Alright, now these different types of rock, we change from one type to the other, and this is called the rock cycle. On slide 4 we see a few more definitions. Magma is the molten material. Remember, we said molten rock is like liquid rock. That's magma below the Earth's surface. When it reaches the surface of the Earth, we call that lava. That's what we see when we see a picture of a volcano. We know that very hot, glowing rock moving slowly down the side of a mountain. That's called lava. That's liquid rock that reaches the surface. Weathering is how things are broken down by the water, the air. Remember, we talked about that with sedimentary rock. And that sediment are the weathered pieces of Earth's elements. I know I'm giving you a lot of different definitions here, so it might be very confusing. To help us understand, let's go on to the next slide, number 5. You can see how this process works. Why don't we start down at the bottom on the left side? That picture on the lower left, you can see there are those large areas of red. Well, that represents magma. Remember, that's that hot, liquid, molten rock. Now, the next step in that process is when that magma cools. It solidifies. It basically freezes. Just like liquid water freezes into ice, that hot, molten, liquid rock freezes into solid rock. And that solid rock is igneous rock. Now, remember, when that magma reaches the surface of the Earth, like in a volcano, we call it lava. Now, that lava can also cool and freeze and become igneous rock on the surface. So you can see that igneous rock in that picture number 2, above where we started. Now, as we move around the cycle, so now we're at about 12 o'clock here, the third picture, we can see where that igneous rock is carried down into that low area. Rocks in the Earth's surface, they're broken down into small pieces. That igneous rock is broken down into very small pieces. And remember, we learned about, two processes there. We learned transportation and depositing. We said that those sediments are transported, which means they're carried, and they're deposited, which means they're dropped. So they're carried and dropped by water into that low area, and in this picture it's at the bottom of a lake. And so that's where we start to see the sedimentary rock. As we move around, you can see in the next picture there are many different bands that are different colors. We can see yellow and orange and gray. These are different bands of sediment. That's very small pieces of rock that have been carried by the water and then dropped at the bottom of the lake. The sediments are compacted and cemented, and sedimentary rocks form. Compacted, that simply means they're crushed. When you look at that picture, it's easier to understand. Look at all those different layers. Well, think about the layers on the bottom. They're going to be under all that weight from the top layers. So there's a lot of pressure, a lot of weight pushing down on those rocks, compacting them, crushing them. So they're compacted and cemented. Cemented, this means when small pieces fill in the space between large pieces. Think of it like this. Sometimes when you go to a market here in Thailand, you can see some vendors, they'll be cooking chestnuts. And the way when they put chestnuts into the barrel, those chestnuts are round, so there's a lot of space in between. Well, notice the way they cook chestnuts. They take the very small coals and they pour them into that barrel with the chestnuts. Now because those coals are so small, they fill in the space between the chestnuts. That's the same thing that happens with sedimentary rocks. The very small particles fill in the space between the big particles, and that's called cementing. So those rocks are compacted and cemented to form sedimentary rocks. Next, as we move down around that circle, you can see the rock is crushed and it's heated, and those straight bands that we see, the straight lines of yellow and gray and orange rock, become very wavy and crooked. That's where we're going from sedimentary rock to metamorphic rock. As that metamorphic rock gets hotter and hotter, eventually it melts. So we move over there to the lower left where we started. That rock melts. It goes from solid metamorphic rock to liquid magma. So to go very quickly one more time around the circle, the liquid magma cools and freezes into igneous rock. The igneous rock is eroded by water. It's transported, deposited, compacted, and cemented into sedimentary rock. Then the sedimentary rock is crushed and heated into metamorphic rock. Then the metamorphic rock melts back into magma. So that's that's the cycle that rock silicates can keep moving around and around that cycle. Remember, we learned about silicates in our lesson on minerals. This is that process by which they keep moving around to form different types of rock. Remember, we learned in our silicate lesson how there are so many different minerals because the silicates form crystals with many different transition metals, with different alkali metals, with different alkali earth metals. That's why there are, if you look at this cycle, you can understand why there are so many different combinations of silicates, alkali metals, alkali earth metals, and transition metals. And yeah, even halogens. All right, let's move on. The energy that drives the rock cycle, slide 6. The processes are driven by heat from the Earth's interior. We know that the inside of the Earth is very hot. We've also learned about convection currents, how in a fluid the Particles that are very hot will have more thermal energy. They will move very quickly, so the particles will be farther apart, so that hot fluid is less dense, it's lighter, and it rises. So we get those convection currents that we've talked about. That doesn't, remember, we've talked about it with respect to water and air, but the same thing happens with rock. That liquid rock inside the earth can move around in convection currents. That heat pushes the hotter rock up, the cooler, denser, heavier rock can settle. The weathering, which we learned about with sedimentary rock, weathered materials are external processes powered by energy from the sun. And that's what produces our sedimentary rocks. Now let's take a closer look at each of these different types of rock: igneous, sedimentary, metamorphic, and magma. The first one we're going to look at is igneous. There are two basic types of igneous rock. We're going to break igneous rock down into two basic types: intrusive and extrusive. The intrusive igneous rock, these are the rocks that form when magma freezes. Magma hardens. It goes from being molten liquid magma to solid igneous rock beneath the Earth's surface. If you go back and look at slide 5, you can see that where the red areas of liquid, hot liquid magma freeze into gray, solid, igneous rock, this is below the surface of the Earth, so we would call this igneous rock intrusive. That is intrusive igneous rock. Extrusive rock, igneous rocks, are formed when lava hardens. We're all familiar with a volcano. When you see that lava, remember, magma on the surface of the Earth, when that lava hardens, we call it extrusive igneous rock. So intrusive and extrusive are two basic types of igneous rock. All right, we can break these down a little bit farther into the types of texture. Now the texture, that just means I feel a sneeze coming on. All right, texture means how a surface feels. For example, this table would have a very smooth texture, but certain rocks have a very rough texture. The texture of a rock can tell us a lot about how it formed. We can learn about the formation of a rock by its texture. First, coarse-grained texture. Coarse-grained means a lot of big particles, large particles, and very rough surface with very large particles. In igneous rock, this coarse texture shows us that lava or that magma cooled very slowly. You can see a good example of this on the next slide, slide number 9. That's granite. That is a rock with very coarse grains, very large grains. You can see all the different spots of black and white and pink. So very big particles, coarse grains. That means that the lava or the magma cooled very slowly. We went from very hot lava to cool lava very, very slowly. A fine-grained texture. is caused by faster cooling. You can see this on slide 10. That's another type of igneous rock, but you can't see as many spots of pink and black and gray and white. That's because the particles are much smaller. It's much smoother. So we call it a fine-grained texture. That means the rock cooled a little bit faster. Rapid, fast cooling. Next, on slide 11, glassy texture is caused by very rapid cooling. You can see an example of this on slide 12. That is obsidian. Notice the particles there are so small that the rock is very, very smooth, so it almost looks like glass because the rock is so smooth. That means that's igneous rock that cooled very, very quickly. It went from being very hot liquid magma to a solid almost instantly. Obsidian. Let's go back now to slide 12. So yeah, our glassy texture is caused by very rapid cooling. With that in mind, we can go to the final type of texture, which is called porphyritic texture. Now this is caused by different rates of cooling. So if we have a rock sample with many different sized particles, some parts kind of glassy, some parts fine-grained, some parts of it are coarse. So we've got glassy, fine, and coarse all together because parts of it cooled very quickly and parts of it cooled very slowly. That's called porphyritic texture. You can see an example of that on slide 13. That rock is an example of porphyritic texture. You can see parts of it look very smooth and have very small grains. Other parts are very coarse and have very large grains. So that's the texture of igneous rock. The other way we can categorize igneous rock is by composition. What are the actual what's the chemical composition of these rocks? What elements are in these rocks? Now remember our lesson on minerals. We talked about many different types of minerals and what elements are in those minerals. Our first type of composition, granitic composition. These are rocks made mainly of quartz and feldspar. Now remember, we learned in our lesson on minerals that feldspar and quartz are actually the two most common minerals on Earth. We learned that they are both silicates. They're made of silicon and oxygen. And what else did we learn? We learned that quartz forms these large crystals, these large, smooth, straight crystals, because it's very pure. It's only silicon and oxygen, with 2 atoms of silicon for every 1 atom of oxygen. So it has that same repeating pattern the whole way through. So it's very smooth, very straight, and very clear. Feldspar, remember, we learned has silicon and oxygen, but it has many other elements in there as well. It might have alkali metals like sodium. It might have alkali earth metals like magnesium or calcium. It may have transition metals like iron, cobalt, or nickel, or even halogens like chlorine or fluorine. All right. Let's move on to slide 14. We're going to continue talking about the composition of igneous rocks. So we've got our granitic composition with our silicates. The next type is basaltic composition. These are very dark colored. These are also silicates, like granite, but they're very dark colored. So they have they also have feldspar, but they have that darker plagioclase feldspar. The next type, andesitic. These are rocks that have a lighter granite color and basaltic composition with dark colored minerals. And then finally, the last type, ultramafic. These are rocks with iron and magnesium, a lot heavier metals. So maybe transition metals. We're going to take a better look at that on slide 16. But first, I'd like you to look at slide 15, that cliff with those very straight lines. That is basalt. That you can see that it's a silicate mineral, but you can see it's a much darker color than that granite. It's a much darker color than the feldspar, which we looked at yesterday. I realize there's a lot of different terms that I've thrown at you here. We talked about the texture from coarse grained to glassy, from that very coarse grained granite to the glassy obsidian, and then we talked about granitic, andesitic, and basaltic. All of this is explained in the table on slide 16. Down the left side of that table, we see the different types of texture, ranging from the very coarse-grained rocks like granite to that glassy obsidian. And then going across the top, we see the different chemical compositions. I think the important thing to take from this, in terms of chemical composition, notice our granitic rocks, those rocks in the pink column. They have a lot of quartz, potassium feldspar, and they're very sodium rich. So a lot of potassium and a lot of sodium. As we move across to andesitic, we've got rocks that have sodium and calcium. So we've got feldspar with sodium and calcium. Then moving on to the basaltic feldspar, we've got more calcium. So it's kind of a spectrum there, going from granitic to andesitic to basaltic. We go from more sodium in the granite to sodium and calcium in andesitic, and then more calcium in the basaltic. All of these are just different types of feldspar. And then the different textures are listed down there, from going from coarse grained to glassy. Notice by the time we get to glassy, it's all obsidian and pumice, going all the way across from granitic to basaltic. Regardless of the composition, when we get glassy igneous rock is all going to be obsidian or pumice. But notice there, with coarse grain and fine grained, we have a lot of different types of rock there. Okie dokie, let's move on. So that does it for igneous rock. Now remember, when that igneous rock erodes, Those particles are carried by the water. They're transported, then deposited, they're dropped, then compacted by weight and gravity, and then cemented by smaller particles. And that's how we form our sedimentary rock. There on slide 17 describes the beginning of that process with weathering and erosion. That's the removal of rock, the transporting, deposition, when that erosion loses energy and it drops the sediments. So erosion is the carrying, deposition is the dropping. On slide 18, compaction is that squeezing, that compacting, that crushing. Cementation is when those smaller particles fill in the space. Remember, I used the example of cooking chestnuts, and the very small coals fill in the space between the large chestnuts. That's cementation. We have two main groups of sedimentary rocks, just like we broke down our igneous rock into extrusive and intrusive. With sedimentary rock, we've got clastic, which are composed of weathered bits of rocks, and we classify these by the size of the particles. So and a few examples there: shale, sandstone, and conglomerate rocks. You can see pictures of those on the next few pages. On slide 20, we see an example of shale, and that actually has a fossil in it. Sedimentary rocks are going to be the most common for finding fossils, because these are rocks that were formed when sand and mud and small particles were set down over the top of a plant or an animal to form the fossil. Next, on slide 21, you see an example of a conglomerate sedimentary rock. There we go. So we talked about so we talked about clastic sedimentary rocks that are formed from weathered bits. Our second main group, chemical sedimentary rocks, on page 22. These are formed when dissolved substances precipitate or separate from water. A good example of that, if you've ever been out of Bangkok to the west, if you go out towards Samut Sakhon, you can see the salt farms out there. That's where they have the area of flat land, and they let in the seawater, then they close the gate, and then they let the sun shine down on that seawater. The water evaporates, but the salt in the water, the salt which is dissolved in the water, does not evaporate. So after the water evaporates, all that's left is the salt. And then the salt farmers can gather the salt up, and then they sell it, and they always sell it there in those little plastic bags at the stands along the road. If you ever go out on Ramatu Road outside of Bangkok, you'll see many, many of these salt farms. Well, what they're using there is a precipitate. That salt is the precipitate. It's left over when the water evaporates. Well, sedimentary rocks can form the same way. Some of the substances that form rocks can dissolve in water to where we're talking individual molecules. Then when the water evaporates, all that's left is that precipitate. An example of this would be limestone. This is the most common chemical rock. We also have microcrystalline quartz. known as flint, jasper, or agate, and then evaporates such as rock salt or gypsum, and then coal. All of these are sedimentary, are precipitates, rocks that have separated from water. So a little bit different from the weathering and erosion that we saw in the last group. A good example you can see there on slide 23, limestone. Remember, again, this is the most common, the most abundant chemical rock. On slide 24, you can see the classification of sedimentary rocks. Like igneous rock, we break them down by texture, with the very coarse rocks that have large particles going down to the fine rocks that have very small particles. All right. And then we can also, so that's how we break down our clastic sedimentary rocks. Remember, the rocks that were formed by erosion and settling. Then over on the right side, we have our chemical sedimentary rocks. Remember, those are the rocks that were formed by precipitates, like the salt in our salt farms. We break those down by composition. What's the chemical composition? Like the calcite. The first group would be the calcites. Next we have quartz, remember, which we talked about yesterday, silicon dioxide. Next is the gypsum, which is calcium, sulfur, and oxygen. Then we have the halides, which are like rock salt. That's sodium chloride. And then the final category there, the different organic matter that can become rocks. And that's what becomes coal. When organic matter is dissolved in water and then settles underneath a layer of sedimentary rock, becomes coal. All right. Let's move on. Features of sedimentary rocks. Now the features of sedimentary rocks form clues to how and where the rocks are formed. Sedimentary rocks can, when geologists look at sedimentary rocks, they can look at those different layers that were formed over thousands or even millions of years. And by looking at those layers, they can see things like when a volcano erupted and left a layer of lava, when there was a mudslide that left a layer of very fine-grained mud, when there was a lot of precipitates like salt, so there might be a layer that has a lot of salt resulting from precipitation. So by looking at the layers, scientists can actually figure out quite a lot about the history of an area. Right. Let's move on. Our next category. Remember, when those sedimentary rocks are crushed and burned and buried and heated, they're like cooked, basically, we form our metamorphic rock. And remember, I told you at the beginning of the presentation, metamorphic just means to change. That's what metamorphic rocks are doing. Metamorphic changes occur at elevated temperature and pressure. When the rock is very hot and it's under a lot of pressure, like in a pressure cooker, the conditions for the formation are found a few kilometers below the Earth's surface. So metamorphic rocks do not form on the surface of the Earth. Metamorphic rocks form deep inside the Earth. And if you alright, so different types of metamorphic rock. First type, contact metamorphism, occurs when magma moves into rock. It occurs near a body of magma, and the changes are driven by a rise in temperature. If you go back and look at that picture of the rock cycle on, I believe it is slide 5, you can see those pockets of magma, the big red areas. Well, remember, that's hot liquid magma. Yeah, slide 5. So as you can imagine, the rock that's near that hot liquid magma is going to be very hot. And if you look very carefully at the picture, you can see around that hot red magma, the illustrators have put in a little band of purple. Now that purple represents areas where the metamorphic rock is getting very, very hot because it's so close to the hot magma. That's going to be our contact metamorphic rock. So the changes are driven by a rise in temperature. Next, page 28. Regional metamorphism results in large-scale deformation. That means a change in shape. And high-grade metamorphism. Directed pressure and high temperatures occur during mountain building. This produces the greatest volume of metamorphic rock. Agents of metamorphism on page 29, heat and pressure. You can see good examples of all of this on page 30. On the left, we see those layers, just like earlier in the presentation, the layers of yellow and gray and white and pink rock, that sedimentary rock. Notice on the left side, all those layers are flat and straight. But as we go down, the layers become very thin and small because they're under so much pressure from the weight of all the rock that's on top of it. So that as we go deeper and deeper, the layers get thinner and thinner because they're being crushed and smashed thinner and thinner. In the picture on the right, you can see we go from that undeformed rock into the deformed, the changed and twisted rock. So over there on the far right, you can see it says undeformed strata. That just means unchanged layers. It still looks like the sedimentary rock. But there, underneath the mountains, that's an area where that rock is being pushed and crushed and twisted and heated. It's being deformed. And that's where we see the deformed strata. The areas where the rock is all twisted and it looks like a bunch of different ribbons are deformed strata. Alright, let's move on. Let's continue. More agents of metamorphism. Hydrothermal solutions. Hydrothermal simply means, hydro means water. Thermal means heat energy. So with hydrothermal, we're talking about hot water. This is water that is trapped deep in the earth and becomes hot due to all that heat energy deep in the earth, so that with that hot water, often many different silicates and compounds will dissolve in the water the same way salt dissolves in seawater. So you get a solution of very hot water with a lot of different types of salts and silicates. Well, this solution can escape from a mass of water, and it can cause change to the rocks around it. They promote, here, as you can see there, they promote recrystallization by dissolving original minerals and then depositing new ones. So that hot water dissolves minerals and then deposits new ones. Just like with igneous rock and sedimentary rock, we break down metamorphic into two main types. That's foliated or non-foliated. Foliated just means it has the bands. Remember, you could see our metamorphic rock on slide 30. It's very deformed, and those bands are really wavy, but you can still see the bands of white and gray and orange and yellow. Even though they're really wavy, the bands are still there. That will be called foliated metamorphic rock. The other type of metamorphic rock, non-foliated, means we cannot see any bands in the rock. On page 33, we see a classification of metamorphic rocks. Notice we go from our foliated rocks at the very top of the chart down to our non-foliated rocks at the very bottom. The important thing to notice about this chart is that the foliated rock, like slate, they have very fine texture, very small grains, very small particles, and they form those layers. And as we go down that table, the particles, the grains, get larger and larger, and our metamorphism actually increases. So we go from slate to pyrite to schist to gneiss. I believe we have a picture of gneiss on page 34 on the next page, and you can see that on 33 it's in the center of that chart where we're going from medium grains to coarse grains. And that's our last foliated rock. As we move down the chart, we move from gneiss into limestone and marble. And those are non-foliated with much larger grains, very coarse grains. And then there's an example of marble on page 35, our last slide. That is non-foliated metamorphic rock. So yeah, very medium or coarse grains, and by this point metamorphism is so high that there are no longer any layers visible. You got a lot of calcite and dolomite that are all interlocked, and they don't form layers anymore. Alright, so that does it with our lesson on the different types of rocks. I hope that you use this lesson with our lesson on minerals, and that together they can help you to understand a lot of the processes which shape our Earth, and can give you a new understanding of a lot of the rocks and the substances we see every day. Alright, so thanks for tuning in, and I will see you next time.